Good evening, millennials. Today, we'll look at another interesting LeetCode problem often asked in FAANG interview questions. So let's look at the best approach, understand the approach, and write the shortest code for that approach. I'll be discussing various approaches as in an interview. Okay, let's read the question. Course schedule. There are a total of numCourses courses you have to take labeled from 0 to numCourses -1. You are given an array of prerequisites where prerequisites of I equal to AI, BI indicates that you must take course BI first if you want to take course AI. So for example, the pair 0, 1 indicates that to take course 0, you have to first take course 1. Okay, so return true if you can finish all courses, otherwise return false. Okay, so the question seems pretty straightforward, but let's look at the example to understand better. So we are given two courses and the prerequisites array is that it's an array of array, and in that we have given 1 and 0, which means that before taking course 0, you have to take course 1 as a prerequisite. So there are total of 2 courses to take. To take course 1, you should finish course 0. So it is possible because we have 2 courses to take. Assume we have prerequisites like this 1, 0 and 0, 1 and number of courses is 2. It's false because there are 2 courses to take, and to take course 1 you have to take course 0, and to take course 0 you have to take 1. This is an infinite cycle loop and there's no way to resolve this, so it is impossible. Therefore you have to return false. So let's read the constraints. The number of courses is between 1 to 10 power 5. And so remember, you can't write an n-square algorithm. And the prerequisites dot length is between 0 to 5000, the prerequisites array length. So the prerequisites of I dot length is always 2, which means there are only dependencies between 2 courses. And the number of courses and AI BI always lie between 0 and numCourses. So this is an important example to model our question. I'll tell you later on why. And all the pairs in the prerequisites of I are unique. So you have to find a way to take the courses in a particular order. So if you guys have seen our previous videos about topological sort and graphs, you can understand that this is a direct application of topological sort. So I'll explain you what a topological sort is. So basically, given a directed acyclic graph, if we can arrange the nodes in such a way that it's possible to go from one node to another node without a cycle, then it's called a topological sort. So similarly, if we were able to model all the courses as a direct acyclic graph, and if we are able to find a topological sort, then we are able to prove that this is true. For example, assume the graph is 0 is to 1. Let it be 1 is to 0. So which means that to take course, let it be 0 to 1. So to take course 1, you must have finished course 0. So if you can take this in this order, then it's possible to finish the course. But when you have an graph like this 0 to 1 and 1 is to the same 0, it's a cycle, so there's no way to finish it. So I'm not able to represent it properly, but it's a two-way graph, so there's a cycle, so you're not able to finish all the courses. So it's not possible, so we return false, which is the second case. So there are 2 ways to solve a topological sort problem. You can solve it using in-degrees by finding the in-degree of all the nodes and processing the least one by using a stack. You can see our other videos for this approach. I'll be discussing a more simpler approach. So our basic idea is when we say there are like n courses and we have arranged those n things like a graph, we just need to find whether there is a cycle in the graph or not. So what we can do is we can basically color the graph into 3 colors, and in each cycle we can do a 3-color DFS, and then we can find whether there is a cycle in each node or not. If there is no cycle, then it means that a topological sort is possible and we are able to find a path for this question. which means that it is possible to get a schedule. So to model it as a graph, I will just declare a vector of vector int array, so a graph of size numCourses, because it's given that there are numCourses kind of there are numCourses, number of courses. So I create a graph with that number, then I just create a directed acyclic graph. So I just do for auto edge colon prerequisites. Let me sure I get the spelling right. So it's a prerequisites array is an edge array. It's given 2 edges. So what we do is we do graph of edge of 0. To that we push back graph of edge of 1. So we are trying to create a directed acyclic graph between these two elements by pushing edge of 0 to edge of 1. So this is the simplest way to form an acyclic graph. Now we need a visited array. So visit int vector int visited, and this size will also be numCourses, and I will declare it as 0 initially. You can declare it as a bool array because we need only true or false, but we need to do a 3-color DFS, since in each iteration we need to check whether there's a cycle or not. So what do I do is I just iterate through the I iterate through all the courses. So as you can see, the courses are labeled between 0 to numCourses. So you always know that each node has the value between 0 and numCourses, which is this important statement. So always you can just iterate through the numCourses, and you can just check if visited of that node is 0, and if there is cycle with that node. To the cycle function we need to pass the visited nodes, the current node, and the graph. If there is a cycle, and if it's not visited, and if there is a graph, if there is a cycle with that node, then we just need to return false, which means that there is a cycle and it's not possible to take all courses with prerequisites. And if it's not true, we just return true. Now I just write the cycle function. So cycle function has to return an int, so cycle, and it takes 3 arguments: vector int ampersand visited. So we need to call by reference the visited array because it's called by reference, and we need a int the current node which we are processing, and vector of vector int graph. Here you can call graph by value or reference, but it's faster when you call by reference because the graph need not be created again and again. A copy won't be created internally. In this particular question, it gives a time limit exceeded in LeetCode if you just call it by value. So if visited of s equal to 2, so as I said, it's a 3-color DFS, which means there are 3 cases: 0, 1, and 2. So when it's 0, it means that it has not been processed or visited, which is the first case. And if it's 1, it means that it has been finished processing. And if it's 2, it means that it's been processed in the intermediate state and its neighbors have not been processed. So in this case, I just return 1. Else what I'll do is I'll just put visited of SS2, which means that it's getting processed in this stage. So now I will traverse its neighbors for auto x colon graph of s. So I'm just visiting its neighbors. So when I'm visiting the neighbors, if it's visit of x not equal to 1, which means it has not been processed in any of the previous cycles, but be careful, it can be either 0 or 2 because 2 is an intermediate state. And if there is a cycle visited comma x comma graph, then I return I just return 1, which means that there is a cycle. So even in this function, cycle of 1 means if condition 1 will be true, so in this case it will be false. Else I would, at last, after processing all its neighbors, this particular node will be processed. So visited of s, I will change it as 1, and here we return 0, which means that there has been no cycle. So this is the shortest code you can find. I'm just running it. So as I've explained, if you see this, first when it goes, it calls the cycle for each of the non-visited nodes. So that gets called from here. If there is inter between linkage, it calls this function internally from here, where we use an intermediate state called 2, which means that it has not processed its neighbors. So in this case, we know visited of s is 2. That means we just return 1, which means that we shouldn't process it in the current iteration. And here, if visited of x is not 1, which means it's not completely processed, but it can have other values. So just let's submit this. And as you can see, it has been submitted. And previously, when I just submitted the same one, I got a 80% faster result. I just ran it a few times to prevent runtime errors. I've just submitted the same approach, and I've noticed that if you don't have an call by reference for the graph, it gives a time limit exceeded because it creates a lot of copies of graph in stack memory, and this is costly. To understand how recursion function calls work internally, see our other videos. If you can find a more efficient solution, please leave it down in the comments below, and we'll try to update our solution. Thank you.